Today, before we waste any time, let's jump into the real calculation of the solar sizing of the solar battery. Okay, thank you for this channel, and I know we are moving at par. We are moving forward. We are soon finishing the solar system. We started with the solar panel, the regulators. Now we are on the batteries. Then we shall see the inverter, and we cover up the solar system. Then we enter into electricals. Okay, the general electricals. Now today we are going to look at the calculation for solar battery. Okay, how do you calculate? How do you size a solar battery? Okay, today we are going to look at how to size a solar battery. You may be there with the system. You have a solar panel. You have sized the solar panel. You have sized your regulator or charge controller. Now we want to size this battery, where we store which stores our electrical energy. Okay, now there is a formula which I wanted to give you, which you will always use in all your solar sizing or your battery sizing. This formula is, we shall see, let me give you in the big size. We shall say, since the batteries are measured or sold using the ampere hours. Okay, when you're going to buy the battery, they will always ask you how many ampere hours you want. Okay, they sell them according to the ampere hours, and that is what we want to calculate. We want to calculate how do you come up with the ampere hours. Okay, you have designed your system, you have the TVs, the fridge, the lights, but how do you tell that this is the battery I need? This is the formula. The battery is in, let us call it battery capacity. Okay, which is, it will be in ampere hours. Okay, that will be our battery capacity in ampere hours. Now we want to see, how do we tell, which formula are you going to use to find out the ampere hours you will want for your system, for your solar system? Because you can't just go and buy a battery of any ampere hours. There are very many ampere hours on the market: 10, 15, 20, 25, 30, 40, 45, 50, 75, 70, 80, 90, 100, 120, 200. Okay, I think the biggest is 200 ampere hours. But you can't just go and buy. If you have you want your fridge to run, okay, let's say for 8 hours, you have your TV, okay, you have your lights. You can't just go and buy a 10 ampere hour. Okay, you need to do a calculation, which I'm going to give you the best formula you always use wherever you go to any project in solar. Okay, now if we want to use, we shall have the daily, we shall calculate the daily loads times the backup days. The daily loads are times the backup days. The daily loads are your loads: the fridge, the radio, the TV, the lights. Okay, you get the total energy of your daily load, the energy you use. That is, after calculating all your loads, the capacity in watt hours. That is the daily load. Okay, times the backup days. Backup days, I mean the days, the backup, as you hear the word backup, as our battery are used to backing up when solar outage. I mean when power outage. Okay, when power goes off, the battery backs up. Now we want to see the backup days. When there is, let us say, when there is rain, or when it is cloudy, we have no sun for 2 days. Let's consider 2 days. Okay, because it is common to have a 1 day you can have no sun, but at least next day at least sun will come. Okay, now let us consider maximum of 2 days. And this sometimes they call it autonomy. Okay, autonomy. Let us consider it will be 2 days. Now, this is after getting the daily loads times the days when we have no sun. Those are the days when our battery, we shall need this power from the battery to be fully generate or power our loads for 2 days without sun. Okay, meaning we must calculate a battery which is capable of carrying that energy, which can power our loads. Okay, now divide. You divide by the DOD, which I told you in the last video, the depth of discharge. Okay, how long does your battery get, or how long does your battery get discharged? The depth of discharge. Okay, it has its figure. Then it depends which type of battery you're using, either lithium ion batteries or lead acid batteries. Okay, it depends. The depth of discharge, DOD, times the efficiency. Let me write like this. Efficiency. The efficiency is how often, how powerful your battery is going to be. It depends on which battery technologies you're going to use, either the lithium or lead acid. Okay, but I recommend to use lithium because they give much power from the battery for longer hours. Those are efficiency of the battery. How good does your battery going to give you? How long does your battery going to give you power to light your TV, your fridge, and your lights? Okay, that's the efficiency. If the efficiency is too low, meaning your battery will give you power for some few hours. Okay, now if the efficiency is good, meaning your battery will give you power for longer hours, which I recommend the lithium batteries, which are good to give you for longer hours. Okay, now times the system voltage. Let me use voltage. The system voltage, I mean, these are if you're going to use a 12 volts battery, because batteries are arranged in 12 volts, 24 volts, 48 volts. Okay, now are you going to use a 12 volt? Are you going to use a 24 volt? This is the system voltage. Are you going to use a 48 volts? This is the system you're going to use, the system voltage. And this voltage, we said the batteries must be of the same value. If it is 12 volts, or let us say 12 volts, 100 AH, make sure if there are two, there must be 12 volts, 100 AH, and another battery must be 12 volts, 100, the same capacity, not interfere the capacity. Your system will be in fault condition. If it is 24, make sure you use the same capacity value. Okay, now after getting remember we said even when you're using this, determine your charge controller. If it is going to support a 12 volts battery, if it's going to support a 24 volt battery, if it's going to support a 48, it has a technical seal having the information on it, as we see, as I showed you. Okay, now after getting the system voltage, then you will multiply all. After getting this answer, multiply this by the safety factor. You remember when you're calculating the panels, safety factor, in case the customer has added some loads without you knowing, you can calculate 6 bulbs, but the customer will call another electrician to add like 2 bulbs. Okay, without you, the installer, in your absence, you will not know. Now we need to add on the safety factor, which is 1.25. Okay, the safety factor. Safety factor is 1.25 or 1.2. Always, for in case you're not there, because the client may add on some loads without your knowledge. Okay, A technician, you'll design your system perfectly to work on the exact thing you're going to wire. But after some year, also after some months, weeks, the client may call a neighbor, if a neighbor is an electrician, and he adds on 2 lights, okay, without your knowing, and it will affect the system. Now we include the safety factor, okay. We shall see how it comes to a perfecting our system. Okay, now this is the right formula we are going to use. This is the right formula you're going to use whenever you're going to do any solar installation. Always use this formula. Calculate the daily loads times the backup days. We're going to see how we come up. We're going to undress this formula. Don't get worried. We're going to undress this formula and we find out how to find the exact battery using this formula. Daily loads times the backup days divided by the DOD, the depth of discharge, times the system efficiency, the battery efficiency, times the system voltage, the battery voltage, okay? Either 12 or 24 or 48, okay? Now, after getting all this, we multiply it with the safety factor, which is 1.25. And let us try to see what are the factors we need before we start calculating for the battery sizing. What are the factors we need to know? Let us see some of the factors we need to know from. These are the factors, in fact. These are the factors, okay? Now, since we have seen the formula, I've put here our simple formula, the battery capacity. This is the formula you're going to drive, okay? Now, I want to show you the factors to consider when sizing a solar battery. Yes, the factors when you're going to size a solar battery, the things you need to ask yourself as a technician or an electrician or an engineer. The first factor is calculate the daily energy consumption. Always, you first calculate the daily energy consumption of the client. Add all his loads, okay? Calculate all the loads, calculate the time. We're going to see how to calculate it, how we calculate the energy, how to calculate the number of hours, how to calculate the watts, okay? Every day per day, it will be the energy consumption will be this is the energy. We shall see how we calculate the energy, okay? It will be in watt hour because the loads are measured. Let us say a TV has 120 watts. When it is working for 4 hours, then you multiply, you get the answer. The answer will be in watt hour. That is each gadget. That is the energy consumption for each gadget. We are going to see how we do it. The next thing is you must calculate the days of autonomy. The days of autonomy. The days of autonomy, I mean the number of backups. The number of backup days. Okay? How many days when we have no sun? How many days can our battery backs us up? Okay? And this is, you must know the autonomy days. If there are 3, if it is 1 week, if it is 1 month, we are going to calculate, but it is impossible. We cannot stay like 2 days without sun. Okay? It is a bit impossible. At least a sun can come for 2 hours. Then it goes. Yes, okay? Now, the third factor to consider when sizing a solar battery, the system voltage, as I told you in the formula. The system voltage. Okay? No, this is, what is it? Yes, the system voltage. Are you going to use a 12 volts? Are you going to use a 24 volts? Are you going to use a 48 volts? Okay? It will depend on your decision. You can decide that I will connect them in series, then I make a 24 volts. You can decide that you connect them in parallel, which is 12 volts, to increase the current, and voltage will remain 12. That is when you're using the parallel connection. But when you're using a serial connection, you'll end up using a 24 or 48 volts. Okay, only this is the parallel connection, the 12 volts. Now this 24, it is serial connection, 48 is serial connection. We are going to see the serial connection of the batteries, and we shall see the parallel connection of the batteries. The same principle like the panels. Okay, now another point, you must know the depth of discharge, the DOD. Okay, depth of discharge of the battery. This depth of how long does it discharges. Okay, we shall see its efficiency. Now another point is the battery efficiency. You must know the battery efficiency. Okay, the battery efficiency is so crucial in when designing, and the depth of discharge is so crucial, and knowing how fast your battery discharges, that if that percentage you must be knowing. That's the depth of discharge. Now how long does your battery going to supply you with its stored energy? Okay, that's the battery efficiency. How long does your battery, as we said, for lithium is about lithium batteries it's at around 90 and above, 95 and above. Okay, it's so good up to 99, not 100%. Okay, as I told you, the battery system or solar system is not 100% efficient. Now for lead acid batteries, the efficiency you may find when it is 50%. Okay, now meaning lithium batteries are good to use. They give you more hours to light or to use in your houses or in your gadgets. Now we need, after getting all this, we multiplied it. We need to know the safety factor. This safety factor help us, a technician or the designers of the solar batteries or the solar systems, to know even though a client adds on another one bulb, the system will be in position to handle that bulb. Okay, without adding the safety factor, which is 1.2. If the client adds on another bulb without you, the designer who calculated the battery, you don't know. The system will come into some faults, like over-consuming of the battery, because the battery has detected an uncalculated load which is added on the system, and it will be draining very fast. Here it will damage our depth of discharge, okay, and the battery efficiency if we don't apply the safety factor. Okay, some customers, they are good customers, but sometimes they will still do a bit of mistakes. Okay, now let us dig. How do we calculate? We do some example of getting a solar battery, of how to design a solar battery. Let's get into some example of how we use this formula, and you see I'm going to show you how you can design it, and it comes in perfectly by using the daily energy consumption, by using the days of autonomy, the numbers of backup days, by using the system voltage. Okay, we shall select any of these and we calculate our battery. By using the depth of discharge, the DOD, we shall consider the battery efficiency, and then we consider the safety factor, which is the 1.2, and our system will be perfectly designed. Let us try this into our example, and you see very well how you design a solar battery than just going and buy a battery without doing the calculation. Okay, designing the calculation is very crucial, very important in solar designing or in solar system. If you don't know how to design or calculate a solar battery, it means you still have problems in solar systems. You will never install a perfect solar system if you don't know how to design a solar battery, you don't know how to calculate a solar inverter, you don't know how to calculate a solar charge controller, you don't know how to calculate a solar panel, and all we have them in our past videos. How to calculate a solar power the solar panels, how to calculate the charge controllers, all the example you have them. How now we are seeing how to, the formula of how to calculate a solar battery, and this, it will give you a perfect knowledge. And if you master this, or if you're going to design any solar, please write these formulas down. Then you can do the calculation in whatever site you are. It will help you, okay, to do a perfect work. Not, you know, when you do a good work for a client, he will refer you to other, and you will see when you're getting more and more customers, okay, as a technician or electrician. So now let us go and see how we can use all these factors when considering to size a solar battery. Okay, let us go using our formula. Let us use our formula and we do some of the example. Okay. Now we have seen that use this formula to find our battery AH. Now let us try to dig from the formula. Okay, here we have the formula. The battery capacity is equals to daily loads times backup days divided by DOD times efficiency times voltages. Okay, after getting all, you multiply it by the safety factor, which is 1.2. Okay, we have come here to see how we undress this formula. Okay, let us undress the formula. For our examples, I want you to know some of how you can design your solar battery. Okay, designing a solar battery, exactly the way you need to do in every solar projects. Okay, this way of designing, it helps you and help the client not to overbuy something which is not in use. Here, this way of designing is really, I say it's really perfect, the way you can also copy if you're designing a solar system. Okay, we want to start with how do we find the daily loads. Let us first design the daily loads or find the daily loads. Okay, now here comes determine the daily energy consumption. Those are the daily loads on our formula. Let us cover and fulfill the figures in our formula. Okay, determine the daily energy consumption. This is the way you can do your table of appliances, the power which is measured in watts. Okay, hour per day. This is the hours your appliance is using. Then energy, the total energy of that appliance. Okay, in case, for example, we have the lights, you know, the lights, security lights, the indoor lights. Okay, or let us say security lights. Okay, their wattage is power is measured in watts. Now their wattage is 10 watts. We have 6 pieces of lights or bulbs. Okay, then if this is now 60, okay, 60 watts. Because we have the we are looking only on lights. Then how many hours are our lights going to work? Our lights from, let us say, if you start switching on your lights, it's during evening from 7 to either to 11, the time you're going to sleep. Okay, let's say they are 5 hours. Okay, now these lights, 10 watt each lamp has 10 watts, but they are 6. They are going to work for 5 hours. Then our energy which will be consumed by these lights, okay, by these lights is going to be 300 watt hour, because we are going to multiply this wattage times the hour. We get the energy per day. Every day is going to do 600 watt hour. That is lights. Now let us go on television. You have your big screen television, 32 inch or 48 inch. Okay, mostly they have 120 watts. Okay, Your TV will work, you will switch it on for 4 hours. Let us say you're going to see some news at 1 p.m. Then you switch off. Then again you switch on the TV in the evening, or you're from work, you switch on the TV in the evening from 7 to 10. Let us say in the whole day, your TV is going to work for 4 hours. Okay, this is the TV. It has a 120 watts, meaning we are going to multiply this wattage times the hour. 120 times the hours, we get the energy which the TV will be consuming every day, and the energy will be 480 watt hour. Watt hour is the power and the wattage, and this is watt hour is the measure of the energy. Okay, now we go on the fridge. Your fridge, you have your things which need to be freezed. Okay, your fridge is 150 watts. Okay, a solar fridge is 150 watt. Okay, you know, in the fridge, there are solar fridges. They have they are solar compressors. Okay, which work on DC. Now it has 150 watts. It's going to work for 8 hours. So that because our things in the fridge, we need them to be cold so that they don't get spoiled. Okay, now this fridge, it has 150 watts, is going to use 8 hours in a day. The energy which the fridge will consume will be 1,200 watt hour. Watt hour, I said, we multiply the power times the hour, we get the power and the hour, watt hour. Okay, now we find the total energy in a day, in one day, because we are dealing with, we want to find every day our client uses the loads. But what is the total load of his machines or his gadgets in the house? Okay, the total load will be 1,980 watt hours per day. Okay, that is per day. Every day, this is the energy is going to be using. Meaning we need our battery which can handle this energy, so that even though we don't have sun, this battery will be able to drive all these appliances, the lights, the TV and the fridge for all this time. If the lights will light for 5 hours, the TV will be on for 4 hours, the fridge will be on for 8 hours. Without sun, the battery must handle this energy. Okay, now we have found our daily load on our formula. Now we have covered the daily load. Okay, let me write it here. The daily load now we have 1980. That's our daily load. Okay, in one day. Okay, now we need to see what about timers. Let us talk about the backup days. When the backup days that is the autonomy, when there is no sun, when it is cloudy or it is raining, and our panel is not getting the sun to charge the battery. That is the backup. The backup means when there is no electricity, can this battery be able to back up your system? Can your system be working without electricity at night or without sun to charge the battery? The backup days. Okay, let us look at the backup days. Normally, the backup days are during a day, because this we are calculating per day. Okay, a day, and we are getting the energy per day, each day, one day. Now we want to also to get, can this battery power our appliances for one day? But the wise part, let us use 2 days without battery charging, or when the power has gone. Okay, you can use a battery charger, no, inverter charger to charge your batteries, but when power has gone or a transformer has got faulty, for 2 days. Okay, or when the battery it is cloudy or raining and the panel is not charging the battery, can this battery power our appliances for 2 days? Okay, on the calculated hours. Okay, if the lights can work for 5 hours for 2 days and the TV can work for 4 hours each day, 4 hours, then 2 days, those are 8 hours. Okay, then can the fridge work for 8 hours in a day? Now if there are 2 days, that is 16 hours. Okay, can our battery be able to handle? Okay, now let us multiply it. Let us make the backup days to be 2. Okay, check this. Let us say number 2, we are looking at the backup days. We say that backup days we are going to consider to be 2 days. That is technical, like you never know. Today there is no sun or there is no electricity to charge your battery. Even tomorrow can be the same thing. So let us take 2 days. Since the total load we got 900, it is in watt hour energy. This is energy. 1980. If this is the total load for 1 day. Now if there are 2 days, 1980. If there are 2 days, this is in watt hour. Don't forget the energy. If there are 2 days, we have considered the backup days to be 2 days. Okay, now times 2. Times 2, it will give you. Now if this is the power, okay, this is the power, and you want to make it for 1 day. Now you want this power to be in 2 days. Okay, we shall get 0, this times this 6, 1, 8, 9, 2, 3. Okay, we shall get 3,960 watt hour. Don't forget this, the energy. Okay, this is going to be the energy. Now it means our backup days. Now we have found the daily load times the backup days. We have got 3,960. Let us do like this. 3,960. That is the energy. The top part, we have covered it. Now we want to see the downer part, which is the DOD times the efficiency times the voltage. Okay. Also, let us check and let us see the DOD of this battery. Okay, the percentage, the rate at which the battery is going to be discharged. We use which one do we use? We use the lithium batteries or the lead acid? We can use the lead acid, which is 50%, or the lithium batteries, which is 90, let us say 95%, the DOD. Okay, now the DOD for lithium, since we have got this, okay, the backup days. Now let us say the DOD for lithium batteries is 90 to 95 and above. Okay, up to up to 99. Okay, this is the DOD, the rate at which the battery will give you light. Okay, now for the lead acid, these acid batteries, it will be 50%. The DOD will be 50%. Now let us use Should we use 50? Should we try to use the lead acid batteries, or we try to use the lithium batteries? It depends on whether you're going to use or which batteries you want to use in your power bank. Okay, let us try to use lithium, because I recommend to use lithium batteries. They are in powder batteries, lithium ion batteries. Okay, let us consider the lithium powder, which is, let us take 90%, meaning on DOD we have got 90%. If you change 90%, this one will come to 0.9. okay, or if you use 95%, it will be 0.95. okay, so let us use this 95%, meaning the DOD for lithium batteries, we are using lithium ion batteries. Okay, lithium ion batteries. Now we have found that, let us use 95%. Okay, we want to be perfect, you know. After getting this, the DOD, we have got 0.95, which let us put here down 0.95. Okay, let us not disorganize our formula, and this is the percentage for the DOD, the lithium batteries. Now, another thing is the efficiency of the battery, or the battery efficiency. The battery efficiency for the lithium batteries, the efficiency is more good than the lead acid. The lithium batteries, the efficiency goes to 90% to 99%. Okay, how often does these lithium batteries are going to give you more energy to use? That is the efficiency, okay, than the lead acid. Lead acid batteries, which will be, it is a bit low, like 70 to 80%. Okay, meaning if you are using the lithium, then we are taking the 90. Okay, it is 90 to 99%. Let us take 90. Meaning our efficiency here, using the lithium batteries, we are going to use the 90%. Let us select 90%. If we are using the lead acid batteries, we may select 80%. Okay, now let us use 90, which is 0. When it is 90%, it is the same as 0.9. Okay, times 0.9 times the voltage. Okay, now we are looking at the voltage of the system voltage. Okay, here we have finished the lithium efficiency, the battery efficiency. We are using the lithium battery, and the DOD also we have finished. The efficiency we have finished. Now even the daily load, the backup days, we have found this in total. Now the DOD is 0.95, the efficiency is 0.9. Now the battery will be the system voltage. We are saying the system voltage. What are the system voltage I mean? The system voltage I mean, are you going to use 12 volts? 12 volts? Are you going to use 24 volts? Are you going to use 48 volts? It depends on your design, okay? Which voltage are you going to use? 12, 24, or 48. Okay, let us take which one? Should we take since our energy consumption, yes, the energy consumption is 3,960. Remember I told you a 12 on the solar panel. Remember on solar panel, I told you when the solar panel is less than, when you calculate your total watts, okay, when it is less than 1,000, you use 12. And when you calculate your watts, when it's more than 1,000, you use 24. When you calculate your watts, when it is more than 2,000 watts, you use 30. You said you use 36 volts. When it is more than 2,000, it means you will use 48. It comes now. It is more than 3,000. Now we shall use 48. Okay, the voltage, the system voltage for this system. Let us use the system voltage. We use 48 volts. We shall come also, we are going to see if we use the 12 volts. Okay, let us use 48. Okay, yes. Now this 48 volts is the system voltage we are going to use. Okay, meaning 48, you get 4 batteries, 4 12-volt batteries connected in series, and you get 48 volts. Okay, 4 12 plus 12 volts plus 12 volts plus 12 volts. All this add up to 48 volts. In series, we said in series voltages increases but current remain constant. But in parallel, current increases and voltages remain constant. Okay, now we are going to find out. This is we have got our formula, and our formula is now full. Okay, our formula is full, and this formula will be, let us calculate it. Let us try to calculate together. We said 3960 watt hour divided by 0.95, that is the depth of discharge, times the efficiency, which is 0.9, which is 90%, times the voltage. The voltage we said we shall use 48. Okay, 48 volts. This is times the factor, the power, the safety factor, which is 1.25. This is how you calculate your formula, the other formula, and you can do all your mathematics in just simple like this. This is the power, the capacity, battery capacity, which I've named to be AH. Therefore, AH will be equals to, if you get this 60 divided by, multiply this. If you multiply this, we said 0.95 times 0.9, which gives you 0.8 times the voltage, the system voltage, 48. It will give you 41.04. Okay. Now this you divide. Let us divide 3960 divided by 41.04. it will give us 96.4. 96.4. Now, this 96.4, okay, 96.49. If you round out, it will say 96.5. Okay, and if you round out this, it can give you, we can say it is 97. Okay, now this is in what hour? No, I mean this is because it is, no, we are finding the AH. This is in ampere hours. But we have not multiplied the safety factor in case the customer has added some loads without our conscious or without our knowledge. This you get 97 times the power factor, which is 1.25. What is the answer? If we get 97 times the safety factor, which is 1.25, you get 121. You get 121.25 AH. Therefore, our AH battery will be 121. Now, this 121 battery, we don't have it on the market. Okay? We don't have this battery on the market. 121. Now, as a technician, you're giving your client AH, because we are finding the AH and we have found 121.25 or 25. Okay, AH. And this is the exact battery ampere hours we need. Now, for a technician, please just add on some extra. Add on some extra for safety purpose. Again, for safety purpose, meaning as me, I will give him a battery of, if the AH, the battery capacity is 121, then me, I will say, check this. I will say, if the AH is 121, okay? Now 121 ampere hours, we don't have it on the market. I will give him 150. I will say, I will add on another small ampere hours, like 29 ampere hours. So it will be 150 ampere hours. This battery is there on the market. I have added on. In case the client has added on another loads, he will not call me, and the system will be able to hold that load. I will give him a 150 instead of 121, which is not on the market. Give him 150. Increase, add on some technically as you, for safety purpose, because you're not, as we said, it is not really perfect. So this is the perfect, but you have added on like 29 to make, yes, it is 29 to make 150. As you, a technician, okay, don't give him exact. Now you add on small for safety purpose. Now check, safety purpose, I mean, there is some voltage drops which will happen in the cable when you're doing the wiring. There is some voltage drops when the inverter is driving, or you are using the inverter losses, the transformer losses. Okay, that is also the temperature when the bulb is giving temperature. Okay, or when the battery is having some temperature, or the bulb, that temperature, that heat, it means the energy loss. That's the energy which is getting lost. Now, if I add on some small ampere hours to be 50, then your system will be working perfectly. Now, which 50? Now check, we have found this 50, but remember we used the 48 volts. Meaning my system will be in series. The battery will be 1 battery, 2 battery, 3 battery, 4 batteries, and each battery has positive, negative, positive, negative, positive, negative, positive, negative. Now I will get this negative to connect with this positive to make 24. If this negative, positive to make 36, negative, positive to make the system to be 48 volts. But the ampere hours must be 150, meaning each battery will be 150 ampere hours, 150 ampere hours, 150 ampere hours, 150 ampere hours. Okay, now this ampere hours, our voltage will be 48 150 ampere hours. We shall use, because in series, ampere hours, the capacity doesn't change, amperes doesn't change. Okay, but in the voltages, this is 12 volts, 12 volts, 12 volts, 12 volts. If they are in series, the voltages increases, which is 48, but the ampere hours, the current stay constant, or the battery capacity will not change. That's why we give the 48 150 ampere hours will be able to drive our load of 3960. And this is how you will do the formula. Okay, let us try to say, some people say, how have you got how did we change the energy to become ampere hours? Okay, now this is our battery will be 48 150 ampere hours, and you will use 12 volts, 4 pieces of battery in series to make 48, because we have used 48 volts. If we have used 12 volts, that will be in parallel. Okay, can we try to use 12 volts here? If you're there, if you have followed the formula, please try to use the 12 volts here. Then you see which answer you're going to get. Me, I have used a 48 volts. Follow the formula well, then you'll come up on what we have come up with. Okay, it is simple and precise. Now, some people are asking how we changed the watt hour. Where does the watt hour went? Let me give you how we did the watt hours. I've given you the watt hour. Where did the watt hour went? Since energy is equals to power times time. This is the formula for energy. Okay, energy is measured in watt hour. This watt hour. Okay, I'm going to show you how we eliminated the watt hour. Energy is measured in watt hour. Power is measured in watts. Okay, and time is measured in hour to make watt hour. Okay, now since in electrical, let's jump into electrical relationship. Electrical relationship, we say, when you're using electrical formula, we say power is equals to this is the formula. Power, the formula for finding the power, the wattage, is voltage times current. Voltage times current. Okay, this is when you're finding the power. Okay, voltage times the current. Now check, substitute the energy. Use the substitution formula. If we say, since the power is equal to voltage times the current, and yet on energy is equal to power times the time, then substitute this power to the voltages and the current. Remove this power because this voltages and current is the same as the power, as we have seen here. Power is equal to voltages times the current. Now here, it means if we get energy is equal to voltage times current. This is now the power. This is the power times the time. Okay, now we have seen this is measured in watt hour. Energy is equals to voltages times current. Now, since this, let me put it in short. V times current is measured in amps times the hour time. Okay. Now, let us see, since current times hour is the ampere hour which we were looking for, then we can say energy watt hour is equal to voltage times AH. Are you seeing how we are driving the formula? Then, this is the AH now. You have seen how the AH has come. The ampere hour for the battery. Now, the battery, since we are looking for this, we can do like this. Voltage will cancel, will remain with AH, meaning AH is equals to this energy divided by voltage. And our ampere hours, we have found how we find the ampere hour. And this is how we came up with our formula, the AH. To drive the AH, this is how we drove the AH. Okay? And this formula, if you apply it, it will help you. This formula is very simple. The formula to use when you want to calculate the sizing of the battery. So now, this is the formula to write or to size all your solar battery sizing. Okay, if you want to size any battery size in solar system, if you want to know the ampere hours, since the batteries are sold in ampere hours, so let me give you a simplest formula you can use when you're calculating your sizing your solar battery. Check this. Let us call it battery capacity. Battery capacity will be equals to daily loads times the backup days, divide by the DOD. This is the depth of discharge. Divide times the system, the battery efficiency. Let me call it efficiency. Times the system voltage. Which is, we call it the voltage. Times the safety factor. Let me call it SF. Okay, and this is the formula to use when you are doing or sizing your battery system. Use always this system. Whatever project you get in solar, always use this system, and it will help you for more future, and you upgrade and advance in designing solar batteries. As we saw in solar panel designing, then we went on designing of the solar charge regulators. Then we have come up another formula how to calculate a solar battery, and this will help you to get to size the proper size of the battery, the ampere hours, because this battery capacity is measured in ampere hours. Ampere hours. Okay, and this is the formula. Thank you for watching. See you in the next video. Don't miss how we connect solar batteries in series and in parallel. I'm going to show you the way you connect them in series and in parallel. Thank you for watching. See you in the next video.